So let's start. Productivity, server-side rendering, you and Elixir. This is the subject of our talk today, but it's really subjective because as everyone in this room, they'll have their own experiences, their own pains. So this is my point of view. Where did I gather my point of view? 12 years of experience in too many companies. Uh, Currently working with Supabase. I've worked professionally with all those languages. The only one I like now is this one and Clojure. I still have a bit of a love for that, but Elixir is the one I mostly love. And one of the things I thought about this talk itself was what defines productivity. So I went to the dictionary and I saw a really boring thing that in reality it's time, work, and money. And agile coaches will say that you need to choose between three, or sorry, you need to choose two. One will be sacrificed, and this is what everyone will tell you. The reality is it's way simpler if you think it as complexity. Everything we do in terms of productivity is to reduce complexity. And why do I think server-side rendering helps in that regard? Well, this is the stacks in a really badly represented way. You either have really static data and you just push it, that's it, which includes a client that needs to connect a server to serve the static information. You have SPAs where you have a client, usually two servers, one for static data, another one for data. Then you have server-side rendering where the same server will serve you static and data, meaning that it reduces the number of services, which reduces the number of servers, which reduces the number of indirections. So whenever you have a bug, you don't need to crawl through how many services you have. Is it front-end A, B, or C? Is it server A, B, or C? No, it's way less things. By consequence, having less servers, having less services, having less code, having less layers of communication ends up in less potential errors, which it's much better. So Elixir is the language I love, and I love it because I think it helps a lot in these regards. And why do I think it helps? At the end of the day, what we're doing with any kind of language, any kind of code is handling data. Static, dynamic, whatever. At the end of the day, everything is data. And what is data? It's this beautiful wall of mishmash, shitty services, some good, some bad, some APIs that are not yours, some APIs that are yours. It's chaos. It's truly chaos because everything fails. There's timeouts, there's server-side errors, there's rate limiting, there's a bunch of shit that will happen, and for sure it will happen. Everything that it won't, it will. Everything is outside. So when we look at this, there's not a single thing here that usually runs within your server. Everything will be a TCP call, a UDP call, a gRPC, HTTP2, whatever keywords you want to use. It's a bunch of shit that you'll need to handle. And everything is difficult. Whenever someone says, for example, Twilio tells you, yeah, it's easy to send a message, but then you need to create an authentication, create an account, check the API key, have your SDK. Oh, there's no SDK for my language, or there is, and the SDK is blowing up for some reason. There's an HTTP client I can use. Okay, I'm going to use the HTTP client. Shit, the body changed because there's a different version. There's a bunch of nuances that will catch you for sure. So everything is difficult. Never fall for the fallacy of it's easy, it's only 2 days of development, it will be 2 weeks for sure. And my opinion is that Elixir is capable of reducing the number of services, which means reduces the number of indirections, which means reducing the number of potential errors. And how does it do this? And now comes the weirdness. So I have a demo here where I'm going to show you this part, message passing. Elixir is really fun because you can actually do quite interesting things. Let's clean up this. Where if you send a message to one node, by the way, disclaimer, we have 3 running nodes at the moment. So basically we have 3 Erlang machines connected together. And that's why whenever I run test here, all machines actually receive this. So and let me show you the code. On our demo 1, if I do just this, bye-bye. What we have is a couple of lines of code. In reality, this part, probably you wouldn't use this in production because this is basically the logic to connect nodes in your local server, in your local host. So let's ignore this part. The full code for a pub sub server can actually be written in a couple of lines of code. We're talking about 20-ish, 30-ish lines of code with comments and stuff, because OTP is a really powerful tool that everyone should leverage. There's one thing called process groups, which is this PG join, that basically stores addresses of processes for a specific topic, which if we go to application, this has spoilers for the next parts of the talk, but it's fine. Where is it? Yeah, basically this guy. I just tell our demo 1, I want to start with the topic message queue, and we just start link with that. We tell it, okay, in your state return topic. I set up the monitors. This is what I called, not the best name probably, but that's fine. And these lines of code are enough for me. Whenever I want to do anything, I fetch all the members for that specific topic, and I have a PID that I can call within my network. So every connected node will be registered to this, and I'm able to do any kind of broadcast, meaning that with, again, a couple of lines of code, we have pub/sub, which means that we can kill a lot of them. We can kill RabbitMQ, ZeroMQ, SQS, and Pusher, and that's the first part. Then we also have storage with multiple flavors, another really not used element of OTP. And if we go to the README, there's in-memory storage. So if I do yada yada, I can actually do this. So this is stored in memory. And if I try to do this here, if I try to get, it doesn't do it. So it's not distributed, it's in memory. It would be good for caching, some quick thing you want to store, really simple, non-persistent data you want to keep just for quick access. But you also have files. If you actually do this, we now have a file called .db somewhere. Let me try to find it. Yeah, this. And this is basically key value storage in a file. This can be useful for example, you want to take down your server, or you've received a signal to shut down. You can grab the ETS contents of your memory, push it into a file, and whenever you're starting up your server, pull it from the file, put it in the ETS. So here you have kind of a failure state that you can handle, or you can do this every X amount of time. So you technically can build a backup in not a lot of code. And before going into the other example, I'm actually going to show those two. The code, again, quite simple. I'm just trying to see if the table already exists. I create a new one. There's multiple ways of creating it. There's bags, sets, and sorted bags, sorry. And then it's basically ETS insert and lookup for basic key value storage. But there's actually a select you can use, so you can actually store really complex data here. You'd be able to select on it. The file, basically the same. The only difference is you need to close the file. That's it. And closing, because from my understanding, this basically opens a stream into a file. And if you don't close it, it might get corrupted. They warn you about that. But again, not that complex. You just need to be careful whenever you write to it, close it. which is honestly kind of expected in most scenarios like this. I've had fun with, I think it was RabbitMQ Redis WAL files just being corrupted because the file didn't close properly. So this is kind of standard. But yeah, with, again, really a low amount of code, we have caching and we have persistency of that cache if we want to, because there's actually functions to transform ETS into DTS and DTS into ETS. So there's really good interop between these two. And again, no libraries. This is all within OTP. Then finally, a more tricky example. We also have an option for, oh, wait, give me a second. I told you, live demos. Oh, I changed the code. But yeah, the idea is, it does not exist. Give me a second. Probably it won't work. I don't care, honestly. I'll accept whatever fate I have. Wait, I need to go back. Nah, it won't work. That's fine. Live demos. I just need to accept it. But the idea is, no, I'm pissed off now. Yes, it will create a table on all nodes. So if I do, sorry about this, it's fine. We'll cope with it. No, or is it? No, this is another one. So if I go again to the README file, if it doesn't work now, it's fine. I'll continue. But let's look at the code while this is compiling. But the idea is there's another OTP module called Mnesia. Mnesia can be seen as a transactional database. It was the database used by WhatsApp for the longest time. So a service that has billions of users. This was their database for a while. I'm not sure if it is anymore because Facebook. But the idea is, let's look, actually this one, let's go through the code because this has a bit of a nuance. Mnesia, again, is a distributed database. And for that distributed database, we need to create this concept of schema and tell it, look, these are the nodes that you're going to connect to. We're going to start Mnesia on all those nodes. And we're going to create a table. If it worked, that's the caveat. If it doesn't work, well, we'll have a really boring demo for this one. Then I have transactions. This is the other good part. Again, it's a transactional database, so you have securities here. Whenever something fails, there's rollbacks. Whenever something happens, you don't get screwed. That's basically the gist of it. But you can also be a ninja and do dirty writes and dirty selects and stuff like that. So you can actually go all in and say, look, I don't care about any kind of transactional things in my life, so I'm going to just go for it. I'm a cowboy, done. And then you can actually fetch this in any node. The problem is one of the demos is taking a long time to load, so I'm going to stop this because there's a special thing at the end, so I'm going to accept it. And I'm actually going to load that while I talk about the other thing. Sorry about this, again. Main. Yeah. So I'm going to actually start this one because at least one of them I want running with this special sauce. The others don't need to. But let's continue. But the idea is within the tool set of Erlang and OTP, you have a transactional database when properly configured, and it doesn't need to be that difficult. There's actually Ecto adapters for it. There's libraries that actually help you a lot with it. So you don't need to go through this stupid example. There's way better ways of doing this. I just wanted to show this is part of the toolset out of the box. And this brings the question, do you need a database? And I'm talking against my own paycheck, but it's one of those things that with other languages, I feel you don't think that much. But with Elixir, it might be worth it for you to not go with Postgres, not go with MySQL. You can go with Mnesia for a long time and basically go, maybe this is enough for most of my use cases. I probably don't need more than this. You'll probably regret it at some point because everyone regrets their tech choices. But it's possible. The other good thing about it is process resiliency. And this is another thing we can take a big advantage when working with Elixir, which is I have Docker running, and you're not able to read this, so I'm going to do the following. I'm going to open a new terminal with this guy. So if I do this, again, the special sauce takes some time to cook. That's why it's taking a bit of time. I have Docker running a Postgres instance, and I'm going to kill it. Usually this in other languages could mean, I don't know. Oh, that was quick. So what happened here is everything failed. So we lost our client to Postgres. It died completely. Our software kept going. That's fine. And after a bit, I start up the container again, and it's able to self-heal. In other languages, this is not as easy. Usually you need mechanisms to actually build this feature. Most of the times with Elixir and their libs, this is built in because processes have their own lifecycle. You can basically say your supervisor can control this kind of action. You can say recover X amount of times, try X amount of times. You have logic built within your tool to actually do this. And that alone avoids, I don't know how many libraries in Java built by Netflix. I don't know how many libraries for Ruby. I have no clue actually if there are any that actually do this properly. You bypass a lot of your problems with things that are given to you for free. And that for me alone should be a killer feature. On top of that, there's way more things. And another example of why Elixir is actually really good for a lot of things, I didn't want to leave IEX. I kind of went, okay, I want to be in the REPL. I don't want to get out of the REPL. The REPL is my love and life. So I'm actually going to write a small Docker client because I had free time, I guess. And the code for it might look weird, and it is weird because there's a bunch of Gen TCP stuff we need to handle, but the reality is Docker has internal socket that you can communicate with in Gen TCP or in TCP. So what I did is basically build a Docker client within a couple of lines of code and a lot of data treatment because it's really raw strings that are not beauty. But again, and this was done in 1 hour of code because, again, I had free time. And by the way, all of this was suggested by Copilot. So that was unexpected, and it worked first time. I didn't have to mess with anything. So someone else had to handle this because it's already in the machine learning thing. But again, it shows how complete this toolbox is. We have, until now, databases, server resiliency with supervisors and the actor pattern and whatsoever. We have broadcasting with PubSub and process groups and whatever. So in a couple of lines of code and a couple of demos that worked and one that didn't, until now, just wait, we basically have implemented a lot of interesting things in a really low amount of time. What else? Let's see if the next demo works. I doubt it, because it was also using Mnesia. But yeah, this is what process resiliency actually brings you. One of those problems of everything fails, it doesn't get fixed. It gets a bit mitigated because, for example, a lot of the libs we're looking here, we have on the left column everything here as Ecto adapters and uses Ecto. So whenever a connection fails, we're able to retry. Kafka uses, if I'm not mistaken, HTTP, which is weird. I can't remember which one is it, but I actually checked and it does retry. Elasticsearch, it's an HTTP client. S3 and Minio are XAWS, which also retries. Twilio, Stripe, etc. All of this row and this row, it's Tesla, Finch, whatever library you want to use, all of them support this. Because every time they do a request, they open a process. If the process fails, the supervisor goes again. So again, with really low configuration, with out-of-the-box tooling, with low amounts of code, you have killed I don't know how many patterns that have been developed until now. I can remember, what was it, railroad programming, stuff like that, where if one flow fails and it goes to another. No, you just retry, and if it doesn't work a lot of times, the problem is probably not your app. It's actually network layers, the other guy, whatever. But it deserves a better look than something failed to communicate. I need to go all ends. No, it will retry. Don't worry. Now, this is the demo. I'm not sure it will work because Mnesia failed once. And fool me once, shame on you. Fool me twice, but I have to try. I have a fourth demo that I hope it works. Yeah. So the broadcasting works. Let's see if the other fancy part works. So here what I did is basically collect the idea of PG, so process groups. And yeah, works. Okay. And Mnesia. So see this as the example for Mnesia. Forget the other demo. This is the one for Mnesia because this one is working. What I did here, it's basically mini Kafka. In a couple of lines of code, I have in both nodes a worker that runs a piece of code whenever something is broadcasted, which is this warning important, warning information. That's broadcasted to all connected nodes. Whenever I want to fetch, I can tell it, look, get me all the events from a certain timestamp. It goes to Mnesia, it fetches that data, and you can replay it, you can do whatever. So this could be a lot of lines of code, but honestly, it's not that much. So this is the front end of this service. The only thing I do is set up the gen server where I say to it, look, for topic X, given a module X or Y, run the function something. Okay. Then I tell it your way of starting up the server, this gen server will be with first connect nodes, then connect to topic, then connect to DB. So this is a really handy trick if you are doing gen server stuff. This handle continue is really useful because usually when I started working with Elixir, everyone had everything in init or start link. It was never well defined. Usually it was init. The problem is init has a timeout. So more more cost-heavy things would fail miserably. This kind of mitigates that problem and makes your workflow of starting up a child way more clean. So I start all of that. I connect to the DB, and again, it's Mnesia. So I create my screen. I start it within this node. So imagine that I have server 1 running. It was the first one to boot up. I set its own options. I tell it to go through all the members of a given topic. I tell it to reject my local server because otherwise it's just noise. And I send to them, look, connect to this node because we have Mnesia thing running. So you need to connect to this node as your Mnesia master. So again, you don't need to live with this. There's way simpler ways. I just wanted to show with bare bones things that you can do it. Don't. Please be don't be your enemy. But after connecting the database, we basically do a broadcast. On our broadcast, we do a transaction where we basically save the content, and this content can be maps, can be whatever. Choose your own poison. That's completely fine. It just needs to comply with a certain format you've defined here. So I said it. There's a timestamp. There's content. That's it. Those are the only keys that it cares about. And then you just do pub/sub. This is pub/sub in one line. After that, imagine that you want to replay your events. This is something Kafka offers, where you say, look, from topic X, it's the persistency layer of it. If from topic X, replay the events since yesterday, so I can reconstruct them and do whatever I need to do, it's just a fetch from topic, which has, it's this code again. A select within a transaction, and this is another really fun part of it. It's basically locking. So again, it's a really strong transactional database. Even selecting requires locking. You can do it with dirty selects without the guarantees of persistency of atomic behavior, which is fine. It depends on your use case. If you want something that to be sure, for example, fintech stuff, if you want to be sure that something happened, do it within a transaction. If it's something that it's not as important, kick it. That's fine. This is the other really, really ugly element of Mnesia. There's libraries to help with this. This is their select syntax. We're saying that our table matches this format, which is table name, timestamp, content, which is argument 1, 2, and 3. From this, I want everything bigger than, everything that where the number 2 is bigger than TS. And then we run it and we say we want the full content of it. So again, not pretty. There's libs to help with this. Please don't be your enemy. Don't try to go all in on, oh, dependencies are the worst thing ever. They are your friends, don't worry. And yeah, I also have here some connect logic. So imagine that server A starts first, server B starts second. This is basically the logic to set up Mnesia to accept new nodes. So a new person will connect with this logic, and it uses master, and after both call and the slave node, which is not the best name, but yeah, the slave node will recreate everything on this side. There's this wait for tables. It writes everything, done. It warns the other person, okay, I'm ready, and everything continues from there. So this kind of brings to the idea that we can also kill Kafka. From this list of things, we have now killed several services, potentially, 3 rows, and this is only the beginning, right? Because if you actually think about it, we were talking about this SQLite. Maybe you don't need SQLite because you have the ETS. You might not need, I don't know, choose your poison, I guess. Choose the service you think about. You might not need it. And that, for me, means that everything fails. And we kind of, again, we don't fix it. We handle it, which is good enough for most of the times. We have retry logics. We have supervision trees that do all their magic. We have a bunch of things that just take care of that for us. Everything is outside that can or could not be true. It depends on your choices. But for example, why do you need Redis at this point? There's no good reason to have Redis when you have, at least for the biggest use case of Redis, as I've seen in my 12 years of experience, it's basically used as a cache or a pub/sub or a mix of both or just a data dump of things. ETS handles that, DETS handles that, and you just have that in-memory database within your tool set. And it's one less communication protocol, it's one less layer, it's one less service you're paying AWS, it's way less things. And this goes, again, for other databases with Mnesia and DETS. And everything is difficult. We kind of solved that, and we didn't. because as you saw, the logic kind of sucked sometimes. You need to know a lot of the submodules and modules and shit, the syntax and the demo failed and all of that. It's part of it. It's the growing pains of learning something new. But the reality is, after you learn it, you know that, okay, PG exists, ETS exists, DETS exists, Mnesi exists, and within all of this, GenTCP exists. You know that at least the modules are there. So it's hard on the first day, it's hard on the second, but then you kind of go, okay, at least I know I have something out of the box. I don't need to learn a new syntax, because at the end of the day, you're writing Elixir to actually bump up most of those things. Again, goes back to the idea of one less indirection layer, where you don't need to extend your knowledge above your language. You can keep it there. You don't need to know. You don't need to go to the Redis webpage and look at that site table with I don't know how many commands. But by the way, I actually really like Redis. I think it's one of the best technologies ever. I just don't use it anymore. But yeah, it's still difficult, but it can help you a lot. And again, dependencies go a long way. Amnesia doesn't need to be that hard. And that kind of difficulty kind of goes away slowly because you're working with only one stack instead of working with your code, another service, another service, another service, another service. It just reduces that by a lot. What about server-side rendering in Elixir? Everyone knows this one. It's no surprise that, yeah, it's kind of expected. Sorry, no spoilers, but it's probably the best thing that happened in web development for the last years, and that's why Hotwire and I think it's Laravel or something like that is actually LiveWire, right? Yeah, they're basically going, yeah, this is a good idea. And actually, LiveWire was developed, I think, in not it was kind of a coincidence. The LiveWire guys were already developing something similar to LiveView, and they actually exchanged ideas on how to do things because they kind of went into the same solution. If I'm not mistaken, don't quote that. But I truly believe this is probably one of the biggest revolutions in terms of web development in the longest time. And it really changes things a lot. Because you can do real time with PubSub. Again, I built a PubSub a couple of minutes ago. I probably don't need to do that ever again, and that's fine because we have one within our code. So I'm going to go to my beautiful application. And if I open another one, if I go here, yeah, one client talks to the other, no fuss, no nothing. And if we go chaos mode, we can actually update the DOM quite fast. And this is actually not the fastest. We can go a bit faster. Let me actually do that because it's funnier. Live one. And here I'm going to replicate a bit the iterative nature of LiveView and Elixir and whatsoever. But yeah, we can actually update the DOM quite fast. Still working, it's not blocking. It's auto-scrolling down, and I'll show you that why in a bit. But yeah, as you can see, it doesn't have a lot of pains. It's a language that, not a language, sorry. It's something that actually supports really well, and it's only doing DOM manipulations. But really, really fast, because the LiveView packets are really optimized. You basically, but this is actually the browser. That's the cool part, because at the moment, we probably have millions of DOM entries. And let me actually, yeah, our console probably is dying a lot. Yeah, as you can see, it's, yeah, it's actually Chrome that is breaking. Chromium, not LiveView. Yeah, it just barked completely. But yeah, as you can see, Elixir is still fine. It's still working, and it was sending messages. And We all know about the signs, we all know about that. So I wanted to do something different. And why is it not blowing up in Elixir? In theory, it should blow up because I'm sending a stupid amount of message, and if I use assigns, it would bloat my memory. So I've used streams, which is a new thing for LiveView, newish, I think, .17 or 18. They've introduced this, where basically whenever you send through a stream, it doesn't store within memory because each connection is a process. Each process has its own memory, so be aware of that. So each connection has its own memory. So if you pump 10 gigabytes of information, you'll have a process with 10 gigabytes of information. But the reality is this kind of fixes that. This does a lot of JavaScript magic where it just inserts something somewhere with the right ID where it is actually able to manipulate that. And I'll show you that a bit later. But yeah, the idea is I subscribe to my message topic. I create a stream for my view. I tell it that it has a hook. We'll go into that later. And this is one of the main reasons why I think LiveView is more disruptive than, for example, Hotwire. But we'll go into that later because, again, opinions. I tell it, look, draw from this stream, just draw an element. That's fine. And again, the events are basically an handle event whenever something is broadcasted. So this is the click or enter to submit. It receives a message, it broadcasts it, puts it in the stream, pushes an event to JavaScript to say scroll to the bottom. Then there's chaos mode, which is the same, but just constantly broadcasting and sending another message to PubSub to keep broadcasting. So it's basically feeding itself garbage. Again, why do I think LiveView is disruptive, and I think it's way better than other frameworks for server-side rendering? It's actually the interoperability with JavaScript. One of the things I hated with this demo was whenever I turned on chaos mode, scroll was always up. I researched, and the only way to do it is with scroll to the bottom with JavaScript. And that was, okay, this is perfect because then I can show this. Because let's be real, you cannot do anything in this world for the web without JavaScript. And that's the pure reality of it. As much you can run and hide from it, you'll need JavaScript at some point in time, which is the paradigm that, for example, Hotwire doesn't follow. They kind of advise you to use Alpine, if I'm not mistaken. But at the end of the day, you'll need JavaScript to do complex stuff. Either graphs, whatever, you'll need this. And hooks are kind of the sweet balance between both, because I can actually send message from Elixir to JavaScript, but also the other way around. I can actually send messages from JavaScript to Elixir, which means that I can actually have interoperability between my client and server within the same WebSocket really easily. And this for me is one of the game changers for LiveView. So then there's the next demo, which is, go away, yeah. Presence. This is the other feature I really like about Phoenix. You don't need LiveView for this. You can have Phoenix only for this. And the idea is that if I join, there's automatic presence. Ignore the cat, it was the only auto-generated avatar that I actually found. But yeah, it still works. Everything is fine. I send potato, it responds with potato. But the idea is, from the box, I can actually have presence. In my past, I've seen presence being done in Rust, in Pusher, we actually didn't go with the best technology possible, which was, it's actually built in Erlang, which is Azurebird. It's a protocol I don't remember at the moment. But yeah, it's basically a presence service you can have. But Phoenix can actually offer you that. If we go to Live 2, the only thing you need to do is when the socket actually connects, you just say to it, track the presence of this user and at what time did it get online. Here you can send any metadata you want. And then you have presence list, and that's it. Out of the box, in 2 lines of code, you have a presence service. Oh, sorry, more lines of code. Because then, this is the unelegant part of live view and of presence. And I think this one actually should be rethought about it. You don't have a clean way of saying that someone disconnected. So you need to keep track of who disconnected. And to do that, it's not the end of the world, but it's code that we could avoid, where we basically have a gen. I use the gen server again, and the idea is it calls itself to check if from the processes I've recorded as present, who is still alive. Because whenever you open a live view, it actually opens 3 processes that I know of. Probably there's more. One for the transportation layer, and there's another one I don't remember at the moment, and the one that actually retains a lot of the information. So yeah, you need to kind of check if is it alive? It is not. Otherwise, it doesn't track when you leave, which is really annoying. And there's a really good thread about that discussion in GitHub with a lot of participations from Accord, but it's kind of I think there could be better ways of solving this, because it really feels like a bit iffy. You could probably have this natively, but yeah, again, not a lot of lines of code, and again, everything else it's basically easy, which is this part. Whenever someone joins, you basically assign a new user, and this will get drawn within your view. Whenever someone leaves, this is the one that the monitor triggers. So basically, the monitor checks if the process is alive. If it's not, here's a pub/sub event saying you've disconnected. Okay, remove it from the list. Again, this is not the most elegant thing, and there's better ways to do it. Still, I wasn't able to find one in time. And now comes the special sauce that I've loaded, hopefully, which is what I think can be the next big thing for Elixir, which is this library. Probably everyone has saw this image by now, hopefully. If you don't worry, you're still in time. And we basically go here, presence didn't work, perfect. So machine learning is all the rage now, and it's really cool and everyone loves it. And don't forget, this is running on CPU, so that's why it takes 2 hours. But the idea is you can actually do this quite easily, and we're basically doing ML on each message to say what's the emotion of the message and what's the topic of the message. And the code for this, probably in other years, would have been, forget it, I'm not going there, I gave up, I'm not going to implement that feature, to actually quite manageable amount of code, which is here. So ignore this if. This is the special sauce flag. If we remove it, we're basically saying to it in a couple of lines of code, probably 20-ish, that I want to load one model and one tokenizer, so a way of splitting strings. And I want to load another module and another tokenizer for another purpose. So this one is for the emotion analysis, this one is for the labeling part that basically defines the topic. These are things I don't understand. I have no clue of the impact of saying what's the batch size, whatever. I think this is related with, this part is the concurrency of this XLA thing, the sequence length, I guess the string length that it can take. I have no clue. Please read, research, and don't be afraid. I am. That's why I haven't searched yet. And then we just say, this is using Bumblebee, which is a library you should really be watching in the next couple of years, months even, because there's some really cool stuff coming out in soonish from what I've seen in the PRs. This uses NX in the backend. NX is a vectorial library for Elixir that actually runs on GPUs. Soon it will run on Mac. There's already hints of that, which is good because this demo would be way more fun. Because then I could turn on chaos mode probably. And it has a concept of serving. What serving does, it's basically abstract the calls to the model. And when it calls that model, it will run in this EXLA thingy. See magic. Ignore it for now. Learn at your own pace. But yeah, it basically loads that serving, which is the way to serve the module. We do that for both libraries, both modules, and we give it a name. And then on our code, what felt like impossible a couple of years ago to actually build, it's resumed in these lines of code. So in 2 lines of code, sorry, 1 line of code, we're calling the module. Again, we're calling the model. We're getting the result. This one, again, another model. And again, this is not optimized. In theory, you should probably call this in separate processes. Again, I was a bit limited in time, so I was spending my time doing the Docker client instead of doing this. So yeah, you in 2 lines of code, you're actually running machine learning algorithms with 20 lines of configuration, with open source models. And it wasn't that painful because then we're running this within a task async. Whenever the process is done, we just need to receive the results. And again, live view being awesome. The fact it actually recognizes that it's the same message because it attributes an ID to it and updates in the stream. Again, nothing in memory was used. It goes into the DOM. It finds the right element within that DOM and updates the element without extra lines of code, just an update. And I think that concludes the talk. So if there's people that are still not sure of trying Elixir, please try it. Worst case scenario, again, you'll have fun because it's a fun language to work with. And even I was actually commenting, I went to bed at 3 a.m. and I needed to wake up at 7 a.m. because I came from Lisbon. I went to sleep at 3 a.m. because I was distracted with the damn Docker client because I was trying to do a LiveBook app because now if you have LiveBook, you can actually build apps on it. And I was trying to do a LiveBook app for Docker. And that was stupid. I should have went to sleep. But again, I was having fun. And if anything, that's the biggest disclaimer. Have an alarm to stop you because you get distracted easily. And yeah, that's basically it. Use Elixir, use server-side rendering, not bashing against other methodologies. They're fine too, but consider it at least, I won't say refactor, but think about a new project that will cost save a lot in the company. And again, try to use Elixir for that because it's hell of a fun moment. But yeah, that's it.
So thank you, Filipe. If you have questions, now is the time.
I have a question. How do you feel about the introduction of types in Elixir? You said 50 questions.
I'm okay with it. I think it's pick your poison, you know? We kind of have types with dialyzer. Someone will kill me for that, but yeah. Not types. We have suggestions of types with dialyzer. They also work really well for libraries. So that's the thing I want to see improved a lot. It's when we have types in Elixir. I do believe the libraries will become way better, because then you can actually do way more than the type suggestions actually allow you to. I hope you have better errors, because I hate the no match error in Dialyzer. I hate the no return error in Dialyzer. I hate a lot of the errors that appear because they don't tell you the source of the problem. They just tell you there's a problem. The types will help a lot with that, because they'll be able to pinpoint where's that specific problem. I don't think it will be mandatory for people to adopt it, and that's the best part of it. It's, if you want to do it, do it. If you don't. That's fine. Ideally, we'd even see something like TypeScript, where you can you can do TypeScript and JavaScript, and you can adapt to it. And I'm not saying use any, don't use any. If you're doing TypeScript, that's a crime. Please don't. But at least you can run, for example, TS and JS files together. So that's a good option. Do that. At least when someone wants to refactor, they know what they need to refactor. They just need to look for the .js. That, I think it's a good addition. I don't think it's as controversial as people think, but I get the fear of it. Because as soon as types appear, everyone kind of goes all in on them, and most of the times they don't fully know how to use them, and I'm speaking against myself. Again, one of my experiences was with Scala, and I still have nightmares with covariance and contravariance and a bunch of other things that I'll never understand, and I'm happy with not having to deal with that anymore. At least until the end of this year, I guess.
Anyone else?
Yeah. On the topic of keeping everything inside the same stack, what's your opinion on the evolutions of Bumblebee that you mentioned they are doing some cool stuff? Do you think that people will actually build their own models, their machine learning models inside the Elixir with NX and Axon, etc., instead of relying on Elixir, and then, as you did, you probably imported the model from Hugging Face, it's a Python thing, indeed, done there. What's your opinion? Will it reach the same?
For sure. I have no doubts. I have no doubts of that, because first of all, Valim is working on it with Sean Moriarty. Those two are wizards, and everyone that developed NX. If you ever want to feel dumb, go look at PRs from NX, from Exxon, from Explorer, and from Bumblebee. You'll never feel so. You'll be humbled beyond belief. You look into that, and it's just insane what they're doing. Why do I believe that they'll be able to do it? First of all, again, Valim said that one of the biggest barriers there is now in ML for Elixir is the learning part of it. And he says with strong conviction that Elixir is a great language to actually do model learning. I also believe that, because again, we're working with processes. Parallelization is not that difficult with processes. Plus, we have really, really good interoperability with C, with Rust, with whatever stack you want that's lower level. So that alone kind of puts Elixir in a really good spot that in theory only Python was doing that well. Ruby could also do it, but I'm not sure why the community didn't go that way, but that's another discussion. The other reason I think it will happen, because ML is all the rage, and you can clearly see that the feeling I have is that Elixir kind of already fixes a lot of the web dev problems. So basically we're talking 90% of whatever developers do, it's kind of fixed. Could be better, for sure. Nothing is perfect, and there's always iteration on it. It's not the only tool for the job. There's probably other options that will be better for you, whatever, that's fine. But the reality is the next step is machine learning, and we can see with all the hype that is happening, it will happen. And yeah, I think as soon as the core team kind of said we're going with machine learning, they really went for it, and they're doing a hell of a job, because in 2 years, thinking about Elixir doing machine learning was not on the table. And now you actually have Hacker News discussions kind of going, yeah, I'm building models in Python and serving them with Elixir, because that's actually something you can do. You can build your models the old-fashioned way, I guess, because it's not that old-fashioned. It's kind of, it's unfair to Python, but you can build your models with Python and then use something else to serve them. There's a talk from Sean Moriarty actually talking about that, where he built the model in Python, a specific model for, I don't think it was a large language model, it was something else. And you actually, after building it in Python, served it with Elixir. So that shows that in 2 years, we were able to serve models in a really consistent and really performant way. We just need that last part, the first part. And the work with Axon can help with that, NX can help with that, and NX is basically, probably will be the main driver for that. But yeah, I do believe that machine learning in Elixir will become a thing, and it might take time, but it will happen, almost for sure. But again, opinions.
I hope you like it, and thank you again, Filipe, for being here, and thank you all for also being here. So thank you.